Hi, I'm Elizabeth Christensen, a Postgres contributor and a member of Snowflake's developer relations team. I'm so excited to talk to you today about Postgres and Postgres with AI. Postgres has experienced a huge surge in popularity recently, and in this talk, we're going to talk about why Postgres is so popular and why we're bringing it to the Snowflake platform so developers like you can use it alongside everything else Snowflake has to offer. This talk is mostly for people that are familiar with Snowflake and want to learn more about Postgres, but if you know a lot about Postgres, you're going to want to stick around for the demo at the end. Postgres has experienced a huge surge in popularity with software developers over recent years, and according to surveys like this one and Stack Overflow, Postgres is now the top choice for developers, surpassing even traditional database platforms like Microsoft SQL Server and Oracle. Postgres has had a long history. The project was initially developed as an academic endeavor at UC Berkeley in the 1980s, and then was later given to the Postgres Development Group in the 1990s. The foundation of Postgres was driven by several ambitious objectives, but the primary one was to develop a database that had a lot of extensibility for a variety of business use cases in a growing and modern world. And the Postgres foundations spent a lot of time thinking about data typing and extensions and how they could make the platform more accessible to people. And the founders had no idea that this would become the most popular database for building AI. But of course it did. And now we're here with Postgres backing modern innovations, research, and different kinds of businesses. Postgres is managed by a global group of contributors who are international and all work at different organizations across boundaries and across organizations to develop Postgres itself. The Postgres project directives state that Postgres can't be all developed by the same company. So Postgres will always remain community controlled and never dominated by a single entity. Over the past 30 years, Postgres has had several 100,000 commits with lots of developers and database enthusiasts participating in the project. And it's completely open source. You can even submit pull requests to the project yourself. Postgres has a very stable release cycle, and a new version is released every year in the fall. They're currently on version 18, which was just released in September, and versions 14 through 18 are currently supported. I want to set a little bit of context for those of you who might be more familiar with Snowflake and analytical processing workloads than with Postgres and a transactional processing workload. And historically, there's been a big divide in the world of data. On one side, you have OLTP, the online transactional databases that handle kind of day-to-day operations of an application. And on the other hand, you have something like Snowflake that's for deep analysis and business intelligence. An OLTP transactional database is more focused on a row-by-row database process. There's transactions, they're optimized for row-by-row execution, and typically the workload is high query rates with very small queries that originate from applications and object relational mappers. The analytical processing side, like Snowflake, is doing large-scale SQL lookups across large batches of data, typically using columnar storage and designed to look at huge collections of data and analysis performed over time or date ranges. And with Snowflake Postgres, which we'll talk about later, we're breaking down the silos between data. Now your transactional data in Postgres can live alongside all of your analytical data in Snowflake, and that's going to enable you to do some really cool things. Let's talk a little bit more about some of the features inside Postgres that you might not be aware of. There's so many reasons why Postgres has become the preferred database for developers. It offers a wealth of features and a diverse range of options for use cases and applications. But it's also very, very reliable. It's ACID compliant, which means it never loses data. It has transactional DDL, so you're never left with a corrupted or inconsistent schema. I'm personally a huge fan of all the SQL functions. I love writing CTEs to break down large queries into smaller actions, and even recursive CTEs are really cool too. Postgres has some great features for really large enterprises, like table partitioning, which will break down large tables into smaller sets and make updates and inserts and even archiving much easier and faster than working on very large tables. Postgres is also notably secure. Many large organizations, governments, banks, and enterprise institutions rely on its open source. And if you're curious about Postgres security, take a look at the Common Criteria License and the Postgres Security Technical Implementation Guide. Postgres offers highly flexible data typing with a lot of different types of data types to support different workloads and applications. I like to use BigInt for incrementing primary keys because BigInt will go into millions and even trillions of key data. Numeric data type is great for financial institutions. For temporal data, timestamp with time zone is great and is accepted as kind of the way to do time in international time zones. Postgres also has custom data typing with domains and enums to ensure data conforms to your specific business requirement. Postgres also supports unstructured data with JSON. JSON-B, which is a binary version of JSON, is a great way to store and work with JSON data and arrays. And these JSON types, the lookup queries are very fast, and they can even be embedded in really large elements, but they're still very performant. And developers who work in API-driven workloads love working with Postgres' JSON-B type. And with JSON-B and all of the flexible Postgres types, Postgres can excel in an environment with both structured and unstructured data. And many developers find that a separate document database is unnecessary. Postgres' robust architecture is significantly enhanced by its extensive and dynamic extension ecosystem. This is really one of the core strengths of Postgres that sets it apart from anything else in the database landscape. There's, I think, over 400 extensions currently available, and developers and administrators can make Postgres exactly what they want with highly specific operational needs and can innovate with AI by using the Postgres extension ecosystem. There's quite a few extensions that come bundled with Postgres that are in what's called the contrib library, and then there's quite a few third-party extensions for Postgres as well that are just packaged and installed separately. I really like the PG stat statements extension. That lets you look back at query times. PG stat statements will log every query in Postgres, and you can look at your longest running queries, your fastest queries, and it's a great place to look if you're trying to make incremental performance improvements. There's also cool extensions for doing things like making UUIDs or the full text search with the PG trigram extension. There's also foreign data wrappers that connect Postgres to external foreign data sources like other Postgres databases or CSV files. And this vibrant community of Postgres' this Postgres extension system is pretty amazing. And some of the extensions really push the boundaries of what you even think Postgres can do. And so I'm going to talk about some of my favorite extensions here in a minute. And then AI too. There's an extension called PG Vector that brings AI large language model embeddings into Postgres. So PostGIS or PostGIS is one of my favorite Postgres extensions. This basically turns Postgres into like a huge open source geospatial database. PostGIS is really the most widely accepted open source geospatial framework, and it is the back end of thousands of mapping applications, and it even has tile and feature services, and there's even like full routing with the PG routing extension. Snowflake is hosting a PostGIS day in a couple weeks on November 20th, and we'll have tips and tricks and stories about using PostGIS. It's free and virtual and open to anyone, or you can see the talks later on our YouTube channel. Another really exciting extension in Postgres is PG Lake. This is actually a set of several extensions that transform Postgres into a powerful data lakehouse. It lets Postgres create, query, and write data to open table formats in object storage like Apache Iceberg, Apache Parquet, JSON, CSV, and even geospatial data types like shapefiles. We just open sourced PG Lake this week at Snowflake, and we're really excited about the project. PG Lake is also the underlying technology that will allow Snowflake Postgres to seamlessly connect to data in your Snowflake warehouse without data pipelines or data movement or infrastructure. So there won't be anything brittle or time-consuming or anything to maintain. Developers can just connect their data sources together easily. The Postgres ecosystem that has all of these features and extensions makes it a great fit for AI. And there's a couple different reasons for this. First of all, it's already the system of record for many businesses, so building more features into Postgres just makes sense for them. And second, when you're building on top of Postgres with the vector extension, you can then use Postgres for retrieval augmented generation, RAG architectures. Many organizations use Postgres for their database of record, so when they add an AI tool, they can add custom individual context that makes their large language model more accurate, and it's customized to their specific needs. Postgres is also a really popular choice for data-driven applications. It can really function as a hybrid database capable of handling both traditional structured data and high-dimensional data with the vector extension. You're probably getting the sense that PG Vector is a really big deal, and it is. It came out about 6 years ago, and it's really taken off. PG Vector introduces a special data type for embeddings, and the embeddings can originate from any large language model like ChatGPT or Claude, or anything available in the Snowflake platform. And PG Vector also comes equipped with index types for high-performance embedding queries, like the HNSW index, the hierarchical, navigable, small world, which is a graph-based index, and kind of the gold standard of indexes, and it's extremely performant even against very large sets of embeddings. PG Vector also stores all embeddings and then provides the SQL interface to find nearest neighbors. And so these same nearest neighbor queries, it just ranks these in order of similarity. So you're really getting that sense that the large language model is helping you understand meaning, and Postgres is using basic algebra to tell how related things are. And this same relatedness search can be used by agents or the application itself. It's the same concept. Postgres can support a generative AI workload as well, and kind of can help facilitate a transition from a broad spectrum of potential outcomes to a set of more defined outcomes. So if you think of a situation where you're building an agentic AI that maybe has at the very top several agents and lots of different possible outcomes, an agent can use the data inside Postgres to decide what its purview of responsibility should even be. And then additional contextualization can give the agent ideas about other things that it can do. And the agent can even use data inside Postgres that has been stored before with agents to know whether or not those agents' actions were successful. And so it can sort of self-optimize and then determine a course of action at the end. And the best part about this is that all of it can happen inside a single database. So you can see that Postgres is not only a great database, but it sets up a solid foundation for AI initiatives too. And now we're bringing it to the Snowflake platform. Snowflake Postgres is a new, fully managed service from Snowflake, enabling the execution of mission-critical workloads within the security boundaries of the Snowflake platform. And this allows developers to leverage the full capabilities of Community Postgres and all the extensions that we've talked about without the burden of installing, packaging, and managing the software yourself. Snowflake Postgres offers a fully managed solution, providing all the necessary features for management, like high availability for mission-critical workloads, read replicas for horizontal scaling, and forks and backups for disaster recovery. It also incorporates advanced extensions and capabilities that I've covered, like the change data capture pipeline that will enable seamless integration between Snowflake Postgres and your Snowflake warehouse. This means no data pipelines, no extra data movement for your teams to deal with, and all your data lives on a secure, governed, reliable, AI-ready platform, allowing you to speed up development cycles and ship new features like everyone else. Now I want to show you all of the cool features that I've talked about and some interesting AI use cases with a little demo. So I'm going to show you how to build a Snowflake Postgres provision, and then I'm going to show you a little bit of the database itself. Then I'll build some Postgres stuff into a Streamlit app. I'm also going to connect Postgres to Cortex Analyst, which is natural language to SQL, which is so cool. And then I'm going to show you some ideas about how you could use agents with Postgres. And finally, I'm going to show you how to do some semantic search stuff with PG Vector, which is less of an AI use case and more just like a feature for your application, but it's really cool and it's really powerful. Postgres can now be deployed from inside Snowflake's Snow site. You'll create a new Postgres instance, give it a name, and then you can choose what kind of instance type you'd like. We have burstable, which are typically hobby or test projects, general purpose machines, or memory optimized if you need additional memory. You can decide the size of instance that you'd like, how much storage you need, and which Postgres version you'd like to start on. You can also choose if you'd like your instance to be highly available. Once you create an instance, you'll get a connection string, and you'll use that connection string to connect Postgres to your application or a GUI or to the Postgres command line interface. So for the demo today, I'm going to log in to Postgres' command line interface, pSQL. And I've built a little sample data set here for us to just look at some sample kind of credit card transactions, and then I'll build a little demo app that's kind of like a budget app. So in Postgres here, you can see I've got some tables for the kinds of accounts I have and my individual transactions. And inside my transactions, I have things like the transaction ID, the merchant, category, notes, and then a status. And I've also added PG vector embeddings. And we'll take a look at that when we look at our demo app. It looks like here under data type, you can see that I have a data type of transaction status for my status column. So let's take a look at what that looks like. And you can see here that transaction status is a kind of enum. And so there's specific elements for that data type, and they can only be pending, approved, completed, declined, or canceled. Now let's look at this Postgres data in a Streamlit application. So I've built a little sample app today based on Streamlit. If you haven't seen Streamlit before, it's a Python framework for building nice apps that are really fast, that are generally kind of optimized for data use cases. Streamlit is now part of Snowflake, and you can actually build Streamlit apps from right inside Snowflake itself. So this little app that I've built today is kind of a budget tracker, right? I've got data that's coming from Postgres, and that's building out my dashboard showing me, my budget, how much I've spent today, how much of my daily budget I've spent. Streamlit makes nice little charts like this one where it shows me, my expected budget and my remaining budget. And this is all cool. We're used to seeing data like this coming from Postgres to a front-end application. What's really awesome is that I can actually talk to my Postgres database with Snowflake Cortex. So for example, I can just ask Postgres a question, and I can say, how much did I spend on dining? And Cortex Analyst is going to go translate that natural language into a SQL query for me and give me the result back. And I built into this little sample app some of the query details. So if you want to see how Cortex is working and the kind of SQL it's sending to Postgres, it'll kind of show you how that works. I also built a little sample of kind of something that you might have an agent do. So for example, you might want an agent to be taking a look at current transactions to see if there's anything unusual happening with your budget or with your credit card transactions. And Snowflake Cortex can tell you, okay, I looked at these and these are kind of unusual. It doesn't look like you normally spend this much money at the Samsung store. And I can, with this little button, tell the agent to go cancel my high amount transaction. And then it just went and canceled that transaction in Postgres and updated it. Snowflake Cortex is a really powerful AI tool that'll assist with any kind of data that you need, either translating that data into SQL or being able to ask questions about the data and get deeper insights about it. I'm really excited that you can use this tool with Postgres itself. Streamlit also works really easily with Snowflake data. So we imagine that many enterprises and customers of Snowflake Postgres will also be using their Snowflake warehouse. So your Snowflake warehouse might be where you send long-term data to look at spending or analysis across a long time view. So that could be part of an app. And in your app, you could have both your Postgres data, like I had here at the top, and then Snowflake data here at the bottom. And I can also use the same Cortex agent to talk to my Snowflake. So I could ask Snowflake agent about any of the subscriptions I have, and Snowflake Cortex will go analyze all of my past data and give me some ideas about what I might want to do in the future. And there's lots of ways to customize how these agents work. Some of them you can require human intervention before an action is taken, or you can set up your agent to do things for you on its own. And you can see how much data I'm able to easily pull out of Cortex in just a few minutes with natural language. I never wrote any SQL. I didn't even have to write an application to write SQL. I can just get all of this data straight out of a natural language chat prompt. I also want to show a little bit about how Postgres searches work. So Postgres has kind of three main methods that it uses for search. The first is the I-like pattern, which is basically a wildcard search, and that's looking for specific text. The second one is kind of a full text search that uses kind of fuzzy word similarity matching that's very popular for text search. And the third is a vector-enhanced semantic search, which is going to use something that is a little bit more looking at meaning rather than just the words and the text inside the data. Earlier, we talked about the PG vector. So for this, I've gotten embeddings out of OpenAI and stored them in Postgres. So let's take just a quick look at using an I-like search, and I'm going to look for breakfast. So nothing was found that was a breakfast search. So I could use maybe the word coffee and I might find something, or I could look at food. Into this little demo app, I built it so you can see the SQL on the screen, which is kind of helpful if you want to know how these different types of searches work. And so you'll see here that I'm using the %, which is the wildcard, and the I-like search. Let's try the same breakfast search with the fuzzy search. So let's look for breakfast here. So this breakfast search is giving me a couple results. It's giving me a few things that are breakfast. It's giving me maybe something that isn't breakfast. So it's not perfect. It looks like maybe some of the things are not what I wanted. It's also doing a query based on the similarity score, and that's how the PG trigram works. It's looking for those specific words and word similarities. Let's try doing the same search with PG vector. I'm going to search for breakfast, and it found 4 results. And all of these are breakfast, and some of them don't even have the word breakfast or coffee in them. It just knows that McDonald's might have been breakfast. And this SQL query works by using the embedding search operator right here. And this is how it finds the similarity searches with PG vector. Isn't that awesome? How much cool stuff we can do with just Postgres and Snowflake tools. I love it. So we just saw a quick demonstration of Snowflake Postgres, Postgres in a Streamlit app, which is wonderful. Natural language, straight to Postgres and back with Cortex Analyst. We saw some agents in Postgres. And then we also saw how you could easily add vector semantic search to Postgres. Pretty cool. There is some demo code available for the demo app I showed you. If you want to build something like this yourself, this will kind of help jumpstart your project. Thank you so much for joining me today for this talk and demo about Postgres. I hope you can see how Postgres' history as kind of a reliable and flexible data platform, along with its extensibility, just kind of made it a rags to riches story. A small academic data project is now the next database that's running huge AI agents and enterprises all over the globe. See you soon.